If you're into using Stable Diffusion for portraits, you've probably seen disfigured faces. This problem is common in text-to-image AI tools, and not even Midjourney V6 is immune. It does fine with a single person in the image, but add more people, and control becomes an issue. Take a look at this Mid-Journey V6 generated image. Zoom in and notice the distortion. Solo portraits are easy to fix. You can inpaint these in Stable Diffusion. But what about images with multiple people? Is it really worth spending hours fixing one image? Good news, I have a powerful extension to introduce. It's designed to fix these problems quickly and efficiently, an essential tool for Stable Diffusion users. I'll walk you through it in this informative video, from installing the extension to understanding its parameters in detail. Stick with me and you'll level up your skills. Let's dive in with the installation of ADetailer. Like any extension, first visit the Extension tab. Click on the Available tab, then search for ADetailer. It usually appears in the list below. Click on Install. If it's not listed, use the second method. Install from a URL using the right-hand tab. Find the URL on the project's GitHub page. Just search ADetailer Stable Diffusion, usually the first result, or enter the URL directly in your browser. I'll include the URL in the description below. On GitHub, click the code button, then copy the URL from the pop-up window. This page also provides detailed installation instructions and problem solutions. Some models might need separate downloads, moving them to the WebY Models ADetailer folder. After copying the URL, head back to WebUI, paste the URL and hit Install. Switch to the Installed tab and you'll find ADetailer listed. Click Apply and restart UI.
Back to WebUI, text to image or image to image screen.
ADetailer will be listed. Let's test its impressive effect. First, generate a picture without the extension. Here, I'm using TXT-IMG with the Magic Mix Realistic model. Feel free to choose your preferred model. I've followed the model author's recommended parameters, like setting clip skip to 2 and using
YOLO
sampling. Predictably, there are issues with the photo. The girls in front look fine, but the faces in the back row are distorted. Fixing each face manually with Inpaint would be exhausting. Thanks to ADetailer's author, we have a solution. Let's fix the seed and open the ADetailer extension. You're presented with a wide range of models to choose from. Start with one of the default models, which I'll explain later. After enabling the extension, regenerate the image. Notice the difference in the preview window. Red boxes surround many faces, each marked with a number. This shows ADetailer processing each face. Once finished, examine the improved faces. Now, compare with the original image. For a clearer view of the improvements, I've prepared a zoomed-in comparison. The distant faces are noticeably better. We initially chose the default Face YOLO V8N model. ADetailer offers many models. There are 14 of them. Choosing can be tough, but let me clarify the differences. These models are divided into 3 categories. Models that contain face in their name are those that deal with the face. If it contains hand, it's for the hand. If it contains person, it's for the body. Deep fashion is an exception. I'll ignore it in this tutorial. In terms of processing algorithms, they're split into 2 groups, YOLO for generalized object detection and MediaPipe for specialized face detection. MediaPipe models offer higher facial feature accuracy. YOLO models, depending on their version and training, vary in accuracy. The picture shows their processing areas. MediaPipe focuses on smaller, more precise areas, labeling multiple facial features, but it struggles with side views or small faces. YOLO handles more faces and larger areas, even including hair and background. I've created a table for easier reference. Let's separate YOLO and MediaPipe for clarity. YOLO has 10 models ending in .pt, indicating the file type. The file name's number indicates the version, currently version 8. The letters S, N, and M represent the model size: small, nano, and medium. Smaller models are faster but less accurate. Consider speed and accuracy when choosing. Let's compare V8M and V8N from the YOLO family. According to my explanation, V8M and V8M are the two most different models in the YOLO family. Let's take a look at their comparison charts. Take a closer look. The differences are quite obvious. V8M looks more detailed than V8N. YOLO also offers hand restoration models, which you can observe in action. Exploring MediaPipe's versions, we have full, short, mesh, and mesh eyes only. To clarify, I've created a comparison chart. Looking at the top part, let's examine full versus short. Full is comprehensive, detecting more facial features. The blue dots represent detected features. Full shows more dots on the girl's face on the far right than short. While full identifies 3 faces, short recognizes only the rightmost one. Mesh, implying a net-like approach, offers a thorough 3-dimensional detection of faces. It excels in analyzing facial expressions. Then there's mesh eyes only, focusing solely on the eyes, ideal for detailed eye restoration. Curious about the figure with numbered boxes used for comparison? Let's revisit the web UI for that. On the left-hand side of the list of options, find ADetailer. Click on it, and you'll be taken to the ADetailer settings page. Enable Save Mask Previews for an image showing the bounding box process. Save Images Before generates an unprocessed image. These images appear in the generation folder labeled Add Before and Add Preview. Max Models sets the number of simultaneous models, like one for face and another for hands. I've chosen 3 models here. Let me show you how it works. To make all the settings I've just changed take effect, I have to click Apply Settings, then click Reload UI. In the ADetailer interface, select Models and Settings in the 1D, 2D, 3D tabs. Now that you're familiar with which model to use in different scenarios, it's crucial to delve into the various options and parameters ADetailer offers. Let's enhance our skills together. First, let's revisit the image generation process. You'll notice ADetailer allows for prompt inputs. So, what role does the prompt play? Let's say I generate an image like this. Let's add a prompt to the ADetailer. Add glasses as a forward prompt and smile as a reverse prompt. The result? A pair of glasses on the face and serious expression. Makes sense, right? This is how prompts influence the output. Let's move on to the other parameter. Detection Model Confidence Threshold. What does this imply? Set it to 0.85 and observe. Only faces with a confidence level above 0.85 get detected. That's the purpose of this threshold. Another commonly used parameter is Inpaint denoising strength. Setting it at 0.8, let's see the impact. The result is overly altered, almost like a horror movie. This parameter adjusts the extent of alteration in the repainting area. A setting of 0.8 is excessive. Below 0.6 is typically advisable. Let's consider another parameter. Reset the Inpaint denoising strength to the default 0.4. Then set the Inpaint mask blur to 0 and examine the outcome. The resulting image might look fine at a glance. However, converting it to black and white and adjusting the contrast reveals an obvious seam. This occurs because ADetailer repairs faces within a rectangular bounding box. When blur is minimal, the transition between pixels inside and outside this box is harsh, creating noticeable seams. Conversely, setting the Inpaint mask blur to 50 results in a different issue. Zoom in, and you'll notice the girl's face seems untouched. That's because a high blur value makes the bounding box effectively disappear, preventing a detailer from detecting the face to work on. Understanding these parameters helps in fine-tuning the output for optimal results with a detailer. That's it for today. Thanks for watching and see you next time.